Alright, so where we left off was I detailed the synthesis of tixobactin analog by the researchers, and now we're going to talk about how they confirmed that they indeed got this compound here below. So they did this by mass spec, and they took a look at the expected mass, and the expected mass was 1244.7361 Daltons, and they took a look at the M plus H ion peak, and here's the peak here, and it was indeed very close to the expected mass of the tixobactin analog. So as you can see, it was nearly exact. It was very, very close, and from there they determined that they indeed got the compound. The NMR spectra did include some further confirmation onto it, but at first glance, when you take a look at this, at the spectra for this big peptide, there's just too many protons to keep track of, and it just looks like a big mess. I mean, you could definitely zoom in on specific peaks and determine a triplet, quintlet because of certain neighboring hydrogens, of course, but the proton NMR is not included in this presentation because of its complexity and doesn't provide much information as far as confirming the product. But they did characterize it, and it's included in the paper. So when they indeed confirmed that they did have the compound through mass spec, they the biological activity of the compound was done using 2 gram-positive bacteria species and 2 gram-negative bacteria species, and they tested meropenem, which is a very resistant antibiotic. It's a beta-lactam ring. It contains a beta-lactam ring and is resistant to the beta-lactamase that we spoke about in the previous slides. And they concluded that the tixobactin analog was significantly, well, not significantly, but it proved to be better in it required less concentration than the meropenem to inhibit the Staph aureus species, and it required a little bit more concentration than meropenem. Here, as you can see, you have 0.40 and 0.33. This is the concentration at which the antibiotics were used in the cultures. And so tixobactin did prove to be as good or better than meropenem at inhibiting gram-positive bacteria. But as you can see here, inhibition of the tixobactin, or inhibition of the gram-negative bacteria by tixobactin analog did not prove to be very good as far as inhibiting Pseudomonas aeruginosa. There was no inhibition present when incubated. So, summary of what we've talked about. So tixobactin analog was synthesized, and the unusual L-allo and duracidine residue was replaced with L-arginine. The biological activity was evaluated, and the conclusions was that when compared to other very commonly used antibiotics such as meropenem, it was better or nearly as good at inhibiting Staph aureus and B. subtilis, and inference. You can come to conclusions that it's potent at inhibiting gram-positive bacteria. The yield was low, and it may have been attributed to the resin detachment that was a very low yield at 38% yield, and definitely need to improve that step.